All right. I know that was a lot of stuff. I know not everybody's fully tracking everything. That's okay. All right, we're doing a lot now, right? Because we went away from the slides, right? Now we're going back to the slides, and a lot of the stuff we talked about is going to be interlaced, and we're going to talk about here now. So that's why we're doing that. And what we did, those two charts, right? That's very important when we get to CCNA. We're going to do all of that again in CCNA. It's going to be very repetitive, so we get that down. However, we'll be able to see now, back in the slides, what is going to be more relevant to us. But we can see the 1,000-mile view right above, and we can see, okay, those suites, how they interact with each other, and a lot of that stuff is going to be repeated. Questions? Concerns? Comments? Okay, we do have some good news at the end of the day for later. But first, even better news, we get to start with a video about the transport layer, which is layer 4. Does anyone remember the protocols that are in the transport layer? TCP and UDP. Here we go.
Network communication. Network communications involves a suite of protocols known as the Internet Protocol Suite, or more commonly known as the TCP/IP Protocol Suite. This protocol suite includes all the protocols used in various aspects of end-to-end network communications, including addressing, routing, and reliability. The TCP/IP protocol suite is also a conceptual model that classifies and organizes the various protocols into 4 different layers: network access, internet, transport, and application. The transport layer includes 2 protocols: TCP, Transmission Control Protocol, and UDP, User Datagram Protocol. These protocols determine how the data will be delivered, reliably or unreliably. It is up to the network application to choose. If the application chooses TCP, the data will be delivered reliably, with guaranteed delivery and assembled in the proper order. Or it can choose UDP, when the data needs to be delivered as quickly as possible, with some tolerance for loss of data. TCP adds some overhead, which means there will be some additional delay. For example, the network application HTTP uses TCP to make sure all the data is delivered reliably. Here the user types in the URL www.mybank.example. TCP is used to transport the information reliably between the user's computer and the web server. The web server, also using TCP, sends the requested data, the web page, in separate segments. Each segment includes a sequence number so the receiver knows if anything is missing and so can assemble it in the proper order. UDP is a simpler protocol used to send data as quickly as possible, even if some data doesn't get delivered. Network applications, such as those used for sending voice and real-time video, can sacrifice some data loss in order for the data to be delivered as quickly as possible. As you can see, UDP does not include any functions for reliability, such as there are no sequence numbers in the UDP segments. To summarize, the applications, such as those that perform file transfers, downloading web pages, and email, all use the Reliable Transport Protocol TCP, whereas UDP is used for applications such as real-time video and voice, where speed is more important than reliability.
All right. Now that we've gone through the whole suite, does that video kind of help us make sense on where those protocols are in the TCP/IP network stack? They're in that transport layer, right? What's added in the transport layer? Port numbers. Abdul Shakur? Yeah, exactly, right? Think about FaceTime. Think about you playing a video game. We'll do a video game. If that doesn't make sense, let me know. But if you're playing a video game, you're playing, let's see, Burnett. You're playing My Hello Kitty Volcano Adventure 3.
That's my favorite game.
It's his favorite game, of course, right? And he's walking down Rainbow Bridge or whatever it is, Mario Kart. Well, let's say you miss this frame right here. Well, by the time, right, it resends, you're already over here. Do you need that frame? Is that relevant over here anymore? No, speed's more important, right? You're already over here. That's in the past, right? That's irrelevant, right? You've got these other Hello Kitty or whatever people attacking you. You don't need that one frame from back here. Same for FaceTime, right? If you're having a conversation, it's not going to go back because then it would be jumbled up.
Because they freeze and then it comes back in frame.
Exactly, right? You lose the frame, and then they're back. Does that make sense to everyone? Yeah. So where speed is important, we're doing UDP. Where you want all of the content, right, like an email, right? You wouldn't be like, oh, hello, I need you to report to HR, blah, 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 fired. Because, what does that mean? I don't know, right? You want the whole email, and same for a web page, right? Warning, Greenland attacks, and then you don't get the rest of it, right? Oh, what did they attack? We don't know, right? But for things where you'd want that whole thing, you're going to use TCP.
And the network decides based on what kind of...
The protocols decide, right? So depending on what protocol you use, it uses TCP or UDP, and we'll work on memorizing those as we go on. So like email, what do you think email is going to use? TCP or UDP? TCP, easy day. All right, let's move on. Let's see what we already know. The transport layer, we want to go back up? Hit escape. All right, let's look at this activity. The transport layer has only one protocol, like the internet layer. False. How many protocols are in the transport layer? Two. What are they? TCP and UDP. Does the internet layer only have one protocol? No, we learned about that already as well. It's got IPv4, IPv6, NAT, that private to public translation, ICMP, which is our ping, HUYA, right? When you say HUYA back, dynamic routing protocols. All right, some application layer protocols use only UDP.
True? Yes. True.
The options were true and false. Some application layer protocols can use both TCP and UDP. This is true. Protocols such as DNS use both TCP and UDP. Some application layer protocols use neither TCP or UDP. False. Correct. Easy day? So if we had just watched that video and I answered those questions, probably would have been, we wouldn't understand what's going on, right? So now we can more easily see, okay, we know about these different layers and recall back to what we've learned. All right, so let's go over the transport layer protocols. So we know the transport layer has two protocols. What are they? TCP and UDP. Let's scroll down. Properties, keep going. All right, TCP. Scroll back up. All right, TCP. This is reliable. It's reliable because when it segments it, it puts sequence numbers on it. And the destination, who it's going to, is going to send an acknowledgement number. So for example, that works like this. If I say 1, 2, 3, 4, 5, 6, you would say 7. Then I would say 7, 8, 9, 10, and you would say 11. So that's how that works. Oh, I didn't get oh, that's the wrong number. They must not have got everything, and they'll resend so you get all the data. TCP also puts together back in the correct order. You wouldn't get an email that reads, morning, good. Hope today good for you. That's out of order, right? It's going to put all the packets in the correct, or the segments in the correct order. Easy day? We know it resends lost data, it delivers it or reassembles it in order. Who ya? UDP. That is just fast. Send it. YOLO. Fire and forget. It's just going to get there as fast as it can because Burnett's got to get to the Hello Kitty village and save the princess, right? We got to get there as fast as we can. And overhead, we know that's anything in excess than the data. So the overhead that's encapsulated in a UDP header is less than what's added in a TCP header. Now that makes sense because TCP has additional things, such as sequence numbers, acknowledgement numbers that we already talked about. UDP doesn't have those things, so obviously it's going to have less. Good? Grace?
So is this like when your phone gets a message but the image doesn't download, or that's not the same?
Well, an image, right? What do you think that image would be, TCP or UDP? TCP, right? So it's probably waiting, oh, I didn't get everything, resend this, and then once it gets all of it, it'll put it together.
Because it's acknowledging that you got a picture, so that's why it's...
Correct, yeah. And we'll break that down a lot more when we get to CCNA. Good? UDP doesn't resend lost data, and just whatever order it arrives in, that's the order that it's displayed. Good? Here we got TCP. 3 basic operations. We have numbering and tracking. We do that with 2 things. What do we call those 2 things? Blank numbers and blank numbers. Sequence numbers and acknowledgement numbers. Very good. It acknowledges the received data, and anything that's not received, it resends. So for example, if I did 1, 2, 3, 4, 5, 6, and before you said 7, but let's say you said 5 this time, right? 1, 2, 3, 4, 5, 6 is what I sent, and you say 5. Oh, well then I'm going to do 5, 6, 7, 8, right? Even though I already sent 5 and 6 previously, I'm going to send those again because that's the last ones you sent to make sure you get everything. Good to go? Sequence numbers and acknowledgement numbers. Those are different, right? So when I say 1, 2, 3, 4, 5, 6, those are the sequence numbers. And when you say 7, that's the acknowledgement. TCP and UDP, what layer are those a part of? The transport layer. Does anyone remember the PDU, or the protocol data unit, at the transport layer? Segments is the PDU. You're thinking DHCP port numbers. RWO, once you're ready. All right, yeah, scroll up a little bit and let's watch this right here. Scroll down, hit play. Oh, okay. So here, TCP, we got 6 segments. We'll send the first 3, and they'll send an acknowledgement. Hey, yep, I got the first 3. Sends that acknowledgement back. All right, I'll send the next 3. So then they send the next 3 towards the destination. And if for some reason they don't make it, they're not going to receive an acknowledgement. So what's the sender going to do? They're going to send them again until they get there. And then the target or the destination sends back an acknowledgement. Who ya? All right, let's scroll down and let's see what UDP UDP is next. Now remember, UDP, fire and forget. YOLO. It just sends it as fast as it can, low overhead. Doesn't require acknowledgments. So let's see now what happens in the same situation. It's still going to segment it into 6 different segments, but now it's just going to send all 6 of them at once. It doesn't need to wait for an acknowledgement. It's just trying to get there as fast as possible. And whatever order they arrive in, that's the order that they're processed in. Easy day? Questions? Cerna? Mac?
So
Where's Mac?
it
Mac's over there somewhere. Okay, Cerna.
does it just depend on like the internet connection on if they get there or not with UDP?
It could be a plethora of different things that'll involve troubleshooting. All right, moving on.
Big part of our job.
That's right. Let's see what we know. Transport layer protocols. Which two statements apply to the transport layer protocols? What are the transport layer protocols? TCP and UDP. So let's break these down. Let's figure out if this is true. Does TCP provide reliability?
Yes.
Does TCP provide data acknowledgments? Yes. Okay, so let's check that one. All right. Does TCP resend lost data? Yes. Does TCP have low overhead? No. So we won't do that. Which one has low overhead? UDP. UDP is fast. UDP delivers data as it arrives. Okay, we'll check that. UDP has low overhead. Yes? UDP acknowledges packets? No. Both TCP and UDP use port numbers. Yes. Both are considered to be reliable? No. Which one's reliable? TCP. Easy day? All right. Moving on. We've got another video. We love these videos.
TCP and UDP use source and destination port numbers to keep track of application conversations. Every network application is identified by the transport protocol using a well-known port number. The source port number is associated with the application that originated the request, known as the client computer. The destination port number is usually a well-known port number associated with the destination application on the remote device, the server computer. In this example, the user has entered the URL www.netacad into their web browser. The web browser is sending the information using the network application protocol, HTTP, which uses the transport protocol, TCP. The user's operating system has selected the TCP source port 1024 to refer to any communications coming from this specific web browser window or process. It is also using the well-known TCP destination port 80, so the www.netacad.com web server knows this data is for its HTTP application. After receiving the request from the client, when the www.netacad.com web server sends the client the data it has requested, it will be sent from its TCP source port 80. In other words, from its HTTP application. When sending the data to the client, the server will use the client's TCP source port as the TCP destination port. In this case, port 1024. This is so the client knows which specific application, the specific web browser window or tab, this data is intended for. If the client opens up a separate browser window, in this case, entering the URL www.cisco.com, a different TCP source port number will be associated with this specific web browser window. In this case, TCP source port 1555. Although the HTTP request message will be sent to a different server, the same well-known TCP destination port number of 80 is used to indicate this is for the HTTP application. When the www.cisco.com web server sends the specific client the data it has requested, it will be sent from its TCP source port 80 its HTTP application. The server will use the client's TCP source port as the TCP destination port, port 1555. When the client receives this information, it examines the destination port number to know which browser window the data is intended for.
All right, port numbers. Port numbers are added in which layer? Transport, right? Awesome. So now let's break down these port numbers, even though we kind of went over it earlier. Now, in that other example, we saw him put him in a URL. What translates a URL to an IP address? What protocol translates a URL to an IP address? DNS, Domain Name Service. DNS. What port number is DNS? 53. And DNS is both TCP and UDP. All right, if you want to browse the web, there's two protocols you can use. HTTP or HTTPS, which is encryption and authentication. HTTP port number is 80 or 8080. So it can be 80 or 8080. HTTPS port number is 443. Hooyah? All right. Now let's talk about email. All right. The post office. We all understand the concept of a post office is where you go and send mail, right? So here we're talking about email or electronic mail. Let's go back to thinking about the post office for a second. Let's say you send a letter. Dear John, it's been a while. I fell in love with this guy, cancer or horses or something like that, right? Does the post office keep a copy of that Dear John letter? No, right? So same thing. We have this protocol called Post Office Protocol version 3. Now the post office, what do they do for you? What service do they offer? They send your mail, right? So this is from server to client. So retrieving your email off of the email server, but just like the post office doesn't keep a copy, this does not keep a copy on the server. Does not leave a copy. What port number is POP3? 110. Now this is email. So let's think about it for a second. TCP or UDP? Email. It's TCP, right? Because we want that entire email. Easy day? All right. Well, POP3 is server to client to retrieve my email, but it doesn't leave a copy. What does leave a copy? That's IMAP. What port number is IMAP? 143. This is email, so what protocol is this? TCP or UDP? TCP. So this is also to retrieve email, server to client, but now this does leave a copy on the server. What benefit does that offer the user? Well, if you're on your PC or you're on your laptop, because the email is still on the server, when you log in, guess what? That email is still going to be there. Your folders will be synchronized, right? You can go on whatever device, and it's all going to be the same. Versus with POP3, you pulled it from the server, so it's just on whatever email client you had on that device. That's the big difference. It's going to be synchronize your folders across devices. Cerna.
What determines these differences?
So we're just going to understand the concepts, right? We're not going to configure email or anything like that yet. Good to go? All right, so that's retrieving email. What about sending email? Sending, what letter does that start with? S. Server, what letter does that start with? S. So this is SMTP. Does client to server or sending. It also does server to server is SMTP. What's our port number for SMTP? 25. SMTP, email. Is this TCP or UDP? It's email. So it's TCP, right? We want that entire email. So think client to server, server to server, sending to the server, starts with an S, SMTP. So POP3 stands for Post Office Protocol version 3. IMAP is Internet Message Access Protocol. SMTP is Simple Mail Transfer Protocol.
So Google, like Gmail would be like, is this SMTP, like Google?
Well, if you want to send email, that's going to be SMTP. If you're retrieving email, that's probably going to be IMAP.
Okay, so it's different.
Correct. Sending versus receiving. Push versus pull. All right, identity management. You all have logged into probably, oh, question first over here.
Interrupt, but I don't have a question. So, like with Gmail or Yahoo, whatever, there would be more than one type of mail protocol.
Correct, there'd be more than one. And especially because one's for sending, one's for receiving. So you wouldn't have email and only be able to send and not receive, or vice versa. So you've got to use several protocols. Word, make sense? Awesome. Great question. So you've all probably used the same computer, but you would be able to log into any computer. Or you go to Compound 3 and log into ITOF as well. Now, there's several reasons for that, but let's just think about identity management, right? To be able to allow you to use network resources, etc. That protocol, one of them is LDAP, Lightweight Directory Access Protocol. And that port number is 389. I don't think we had that on our board earlier, did we? Nope. No, LDAP. So make sure you got that on your other sheet as well. On the OSI TCP/IP, that would be in the application layer of the TCP/IP layer as well. Correct, for protocols. Protocols goes in the application or the top one of the TCP/IP layer. For LDAP, LDAP port number 389. Not to be confused with 3389, which is RDP or Windows Remote Desktop Protocol. We need more time? So, all these email protocols, remember from earlier? Which layer of the TCP/IP model do they go to? Application, transport, internet, or network access? These are all in the application layer. Remember, think of server. These are email servers that we're talking about here. This is the application layer. What's your name in the back? What's your name?
Robert.
Roberts, what you got?
I'm confused because you said that it's in the application layer.
Yeah.
But it uses TCP and UDP, right? So,
Which are in the transport layer.
Yeah.
Yeah. So all of these right here, right? All of these things. Where you at? Yeah. Like HTTP, DNS, DHCP, they all have port numbers. Those port numbers, right?
They
They're
go
either
to
going to
a
be
server.
TCP or UDP as well. So they're in the application layer, but DHCP port number is 67 and 68. IMAP, right, is in the application layer, port number 143, and it uses the transport layer protocol, TCP. So all of these up here, because it's encapsulated, it's going to use these here.
Because they're applications.
Correct. But these down here, they're not because they're further down. It goes this way down here. Robert's good?
I get it. Good.
And you're Roberts, right?
Robert.
Okay. I didn't. All the time. All right, let's go down to file transport and management. Who remembers FTP, file transport protocol, is what port numbers? 20 and 21. Question, Newton. Go back up.
The other thing, why is it in protocol instead of transport? Because I mean, wait, why is it in what? Why is it application instead of transport?
No, I got you, Newton. I'm just going to draw some stuff up to answer your question. We'll use this. So we've got, for TCP IP, in, right? Application, transport. What's the next one?
Internet
Internet
and network access.
and network access, right? So application, we've got IMAP, POP3, DHCP, HTTP, et cetera, right? Transport, we have TCP, UDP. Here we have IPv4, IPv6, et cetera. Here we have Ethernet, ARP, et cetera, right? Well, encapsulation, if I'm sending, I'm going this way, down, right? So if I've got my email protocol, POP3, port number is 110, right? Well, we encapsulate. If I'm sending that, then it gets to the transport layer, and then it needs to add TCP or UDP, which for email it's going to be TCP. Then it gets here, and are we doing an IPv4 address? Are we doing an IPv6 address? And we'll add that. And then we go down, right? We'll add a source and destination MAC, et cetera. Right? Encapsulation, we're sending, so it's going to get larger. These up here, everything up here is going to add on later, sending into either be TCP or UDP. Good? Not good? It wasn't for you. That's okay. We help shipmate. I always forget that one. The last one. Schreier.
I know you said we'll learn a little bit more of why, but it's just I'm kind of confused because I feel like I need to know why what it's all used for.
So if you send an email, right? Think of email, right? In general, like POP3 is an email, right? You start up here. In order for it to go across the cable or wireless, et cetera, it's got to go through all this stuff down here. So, right, we send an email, right? POP3, IMAP, et cetera. It gets here, and it's going to add the port number. It's going to be either TCP or UDP, reliable or unreliable. So I'm sending an email. Do I want that reliable or unreliable? Reliable. Then I get here. Am I going to do an IPv4 address? Am I going to do IPv6? Then I get here. I got to add my MAC address. And then finally, once I've done all those things, then I can send it along the way. Think about you when you get dressed to come to here in the morning. Do you just put on underwear, pants, and yeah, that's my uniform? You're missing a few things, right? So you got to fully have everything that's required to go out. But some days, right, you may put on NWUs. Some days you may put on NSUs, right? But it's still you, right? But maybe you're packaged in a different way that day before you're sent out. Does that help you, Schreier? Or if not, that's okay. What are we struggling with? Sorry, I couldn't hear you very well.
I'm okay. I'm just trying to understand all of it, I guess.
It's a lot. Mechanics?
Okay, so I may or may not have gone a little bit ahead, but I was down here doing like the check to understand it.
If it's ahead, don't worry about it yet. Unless,
But it was like, okay, so it says 440 or port 445. Right there it says TCP. I put TCP. And
and then it says the correct answer is both. So now I'm confused.
Don't worry about it. There's some discrepancies on there.
Okay.
Yeah. All right. Let's come back, right, to file transport. FTP, we said, is port numbers 20 and 21. Very good. All right. So we'll break up later what those two port numbers are different used for FTP. One's for commands, connections, one's for the data. Now, but what really is happening, right, is for FTP, every time I want to send a file, I've got to reopen a port, send the command, and then send the data here, and then close those ports. Oh, I need another file. Reopen it, and then resend it, right? Every time you want to do something to retrieve or send a file, you've got to reopen those ports. So it's a short-term connection. The alternative, SMB, Server Message Block 445, it establishes a long-term connection that allows you to, it's already open, you can send the files back and forth. What's fast, and we were talking about FTP a second ago. What's faster than FTP, because it has less overhead, is TFTP, or Trivial File Transfer Protocol, which is port number 69. All right, there are some protocols that are open source, right? So if you want to go on a website, what's a port number you could use to get on a website? 443, what else? 443 is what? HTTPS. So the other one is 80 or 8080, which are both HTTP. Right? And those are open source, right? Because of course, a lot of people are going to go onto a lot of different websites. You want to be able to get onto a website if you've got an Apple computer, or if you've got a Dell, or if you've got an HP. So those are open source. However, there are some proprietary protocols. Have we discussed what proprietary means yet?
They own
They own, right, the definition, the standards, etc. So there are some that are proprietary, such as the Apple filing protocol, made by Apple for various services within those devices, and that's 548. Cerna?
Would we kind of like patenting something?
Yeah,
Like
they,
own that?
yeah, and other people can use it, but they get a license and pay for it, etc.
So somewhat the same concept?
Kind of, you can think of it that way. Okay? I know this is fast. This is a lot. We're going to repeat this all the time.
Never.
All right, next. Remote access. We want to be able to remotely access something. We already talked about Windows Remote Desktop, which is what port number? That's right, because everyone just said it. I heard everyone say it at once. 3389 is RDP, Remote Desktop Protocol. When we get into CCNA, we're going to learn how to remotely access switches and routers, and you can remote into those the same way you can with a device, using a terminal emulation program, and then you can use two different connections. You can use Telnet, and the text, the data that's transmitted, will be unsecure with Telnet. That is port number 23. Or you can do Secure Shell, SSH. It's secure because of user authentication and encryption, and that's port number 22. Both of those are TCP. We're going to learn a lot about those in the coming weeks. Nas in front of you. Starts with an M? Yeah. Chang.
So what's the, so I know RDP is Microsoft exclusive, right?
Yeah.
So what's the protocol that is like open?
SSH was on it.
So these are
Open source for RDP.
We don't go over that. Don't worry.
Oh, I just want to know.
They're all going to be proprietary for that operating system. There's not one that's going to work for everything because security. Because then that's just a really big vulnerability to plug. But SSH or Telnet would be that. All right, moving on, network operations protocols. If I want to automatically get an IP address, what protocol is that? DHCP port numbers
6768.
6768. Which one's for the server? 7. Which one's for the client? 8. All right, the next thing we have, Banker.
I think everybody did.
The next thing is NetBIOS. This is an older way for computers to communicate over TCP/IP and kind of name the device. Those are 137 through 139. All right, there can be a lot of devices on a network. A protocol that can allow multiple devices or many devices to be managed and monitored is SNMP, port number 161, which is very easily confused with SMTP. The difference is SMTP is what type of protocol? Email, right? Specifically client to server or server to server. SMTP port number is 25, and since it's email, it's TCP. SNMP 161, 162 is UDP. And we talked, we'll skip the next one. We talked about the file transfer that's long term. What protocol is that? Server,
Location.
message,
Block.
or SMB, port number 445. Good? We scroll down. Here are a lot of the port numbers you need in order. But we've talked about all of these already, right? So all it is it's just repeating itself. It's just put them all in one location for you.
Wait, so this one, like this class?
These are the ones we're discussing currently in this chapter.
So would you recommend like the first learn all this?
Yep, this is a good spot, right? To memorize all of these, right? Make some note cards. Spoiler alert, that's not that many.
Something like that.
There are many, many port numbers.
But these are the only ones that you need to know.
These are the ones that are in this chapter. Let's do this. Yep.
Not how, I mean, we have to.
All right, let's scroll down. Scroll down more. All right, let's see what we remember.
TCP.
Port 20 FTP. Actually, we're going to skip this activity because I don't think it's accurate, is it? No, skip this. There's some errors on this one. We'll skip this. And click that. Let me see what is this the same thing? Yeah. Skip this. There's some errors on this. All right. All right. Are we ready for a break? All right.